afternoon, everyone, and welcome to our webinar titled Empower Your Organization to Purchase Power on Your Terms. On today's webinar, we'll discuss a little bit about how thermal energy storage systems decrease total energy consumption by about 15 to 35%, add 3 times longer temperature resiliency to freezers, and a lot more. Before we get started, though, I'm just going to cover a couple of the housekeeping logistics that are good to know in case you want to engage further or ask questions throughout the webinar. So the first thing is asking questions. You should all see a GoToWebinar panel if you are logged in on your computer and not just the phone. So on this, there is a questions tab. At any point, you can type in questions. Our speaker will pause periodically to answer some of these questions, and if we don't get to it right then, we'll save some time at the end of the webinar. When you submit a question, we have the email you use to register, so we can always follow up with you should you not get your question answered completely, or we just don't have time to get to it. So there's always a chance for more there. We'll also have a recording of today's webinar available that'll come out in the follow-up message as well as a survey about the webinar, and we'd appreciate any feedback you're able to give on that as well. With that said, I'd now like to introduce our speaker for the webinar, Colin Coker, Vice President of Sales and Marketing at Viking Cold Solutions. Without further ado, I will hand it over to Colin.
Well, good afternoon, audience. Appreciate you making time to participate in the webinar this afternoon. We have a good format. We've got lots of educational items to discuss, and definitely encourage an interactive session. As Kenna had lined out, is that we've got some tools available through the webinar to pose questions, so I do encourage you to pose those as we go along. No need to hold your thoughts until the end, so please be as interactive as you'd like. Title of the webinar today is Control How You Purchase Power for Cold Storage. We've got lots of different areas that we'll cover today. And I'm having difficulty. There we go. All right. So the changing world of purchasing power is comprised of lots of different areas of discussion. You've got competitive retail energy markets. They've grown tremendously. It's not the old monopoly of the past. You've got different billing rate structures that have changed. You have customers that have more choices in how to purchase energy. There are time of use periods have actually elongated. So just in the last few years, instead of just a few hours, you'll see an extended period of time of use charges. Demand, which is the amount of energy used in any given point in time, has also increased across multiple utilities. Now, I understand we may have a broader international audience today, but I will be using lots of illustrations and examples that are fairly North American-centric across the U.S. and Canada. But many of these variables apply in countries all over the world. Capacity charges are, again, much more onerous than in the past. Capacity is the available generation that's available to come on at any given time. In many markets, capacity charges are a line item. It's a billing charge. In some markets, it's managed in different avenues and ways for billing. But for the most part, that capacity, the ability for a utility to solve for the absolute peak at any point in time, the total capacity needs to be there and ready to go. So why does it matter? The kW, or the kilowatt, is now greater value than it ever has been. And you'll hear a couple of different terms. You'll hear kW as the kilowatt, and you'll hear kilowatt hour. Kilowatt is the amount of energy you use at a given point in time. The kilowatt hour is that energy used over that period of time. The screen's moving very slow, so please be patient with me. There we go. So this is a slide given for illustrative purposes. This is different colors represent different energy choice status within the U.S. and Canada. This gives you an example. When you talk about choices or deregulated energy, it's not always synonymous with just electricity. So some states have both electricity and gas choice. Other states are gas alone. Some states have varying maturity levels of deregulation and customer choice. So again, the purpose of the slide and the graphic is to show that in a broad respect, there are many different avenues. It's not a static play in any given market, and it changes with the region. So one of the questions we ask is, what are driving these changes in these competitive markets? And I'm really having trouble with this moving. There we go. Sorry, audience, we've got a very slow screen here. So some of the challenges are power grid related. The power grid has changed immensely. So, you know, what has been driving the change? You've got a lot of growth in variable generation. So if you think of the wind turbines that are also referred to as the windmills, there's a massive amount of generation now as part of the overall percentage of all generation, including nuclear, natural gas, hydro. An example of a state here we're familiar with in Texas is wind generation represents over 20% of the total generation in the state now. Just a few years ago, it didn't even have close to that percentage. So wind doesn't always blow, so it's variable. Same thing with solar. Solar has grown tremendously over the years, and it also, when the clouds show up or there's changes in weather, you have variation in that solar. There's also shifts in demand curves that are basically, those shifts are caused by a lot of that variable generation, but there's also other things that are occurring on the grid, such as electric vehicles and charging, different types of heat waves. We're seeing a lot of different weather variation than we've ever seen before. There's new peaking, or the absolute highest usage in a given day. That time period has changed tremendously based on different usage habits and also technology. We'll talk a little bit more about that in some of the different curves here in a minute. But overall, there's also impacts as a decentralized energy. So you've got commercial generation on site, which is being used by commercial entities more and more. So all of these have a profound impact on the overall grid. So again, a graphic illustration of what does that look like. These are some really good slides, and it kind of brings home how things change, and it's not static. The top left chart is an example of the New England Independent System Operator, or ISO. The different colors represent different monthly profiles and demand variation. So if you look at the pink, being in July, is vastly different from what's being used in January, April, and October. Seasonal demand, so not just by month, but if you look at an example that we pulled from another part of the country here in the U.S., is the Florida Florida Public Utility Commission, and look at the difference in the curve and the usage demand profile from the summer to the winter. So if you're looking at this from a utility perspective, how do I manage that generation and the different assets that are available to me, whether it's wind, whether it's more standard generation whether it's nuclear or a baseload generation that's on full time, and how do I manage other assets to accommodate that change in demand, both seasonally or monthly. And then finally, the last chart is a very interesting, many of you may have heard this term, it's called the California duck curve. It's an interesting picture. You can actually see the tail, the belly, the back, and the neck and the head of the duck here. But let me walk you through this, and this hopefully will resonate with you on how much impact that solar generation has had on the grid, in particular in California. So if you look at, if you can see my cursor move across the screen, this gray bar was actual demand curve in 2012. So you can see there's a fairly, prevalent and evident camel hump. And then again in the evening, there's a second hump when people get home and start cranking up their devices at home. Well, over time, as more solar has been implemented into the state, you'll see that curve is no longer a camel hump, but is flattened out. And you can see each year that curve has dropped down to an opposite effect. It's no longer a peak in the day on generation that is supplied by the utility, it's being made up now by solar generation that's being produced on commercial sites. And so now you've got this belly of the duck that's occurring, and you can see how deep it's gone now by more and more solar generation. Well, when the sun goes down, something dramatically happens. You've got a 13,000 plus megawatt increase of demand that happens in less than a 3-hour period. So for a utility that has to manage a massive amount of generation and assets, it wreaks havoc on their ability to maintain stable grid environment. So as that occurs, you've got this phenomenon, which is the neck, and then the duck as it starts to taper off. And it happens again the very next day. So this is a very visual and evident example of what's occurring. So what does that mean as far as you as a consumer and the people who provide you the power? And bottom line is utilities are responding aggressively to try to alleviate these challenges. So they're increasing demand charges, they're increasing time of use rates, which those are two different charges. Time of use is the amount over a period of time. Your price per kilowatt hour may change, like for example during the middle of the day versus at nighttime, versus a demand charge, which is an absolute peak during a given time window. And both will show up on your bill, and in many cases more than half the time people that we interact with in the market don't truly understand how much of an impact those charges can have on a bill. So the third thing where utilities are focusing and responding aggressively is they're investing a massive amount of dollars in energy storage. Energy storage is a big buzzword in the market across all sectors and verticals of businesses. The energy storage market is expected to grow 70 times just in the U.S. From today through 2025. And on a worldwide basis, it's much, much larger and exponential. So it's nothing that's just growing here in the U.S. This is a worldwide phenomenon that we're seeing. So here's an example that gives you a graphic illustration on the growth over the years. So if you look at the lighter green and the dark green, these are important pieces of the equation. From 2013, very low amount. Look how year over year the storage has increased in the transition from behind the meter and in front of the meter. And what I mean that are grid scale. Grid scale are large projects that are usually utility funded, that are not assets that are on the customer site. They're basically part of that grid and part of the management responsibility. But if you look at the light green, look at the percentage continues to grow over time of how many or how much the storage capacity has actually grown behind the meter in customer locations. And if you look at 2019, again, over 4 gigawatts of new energy storage coming online in 2019. And again, the majority of that is related to behind the meter implementation. So the worldwide deployment I mentioned earlier is about a 10 gigawatt annually by 2025. So you can see we're a measurable piece of the worldwide growth, but still we've got a massive amount of adoption worldwide in energy storage. So you really, as a commercial operator, you need to be aware of not only the changes in the utility, the changes in the grid, how the utility manages it, but also energy storage is an important part of the whole recipe now. And then we'll talk a little bit more as we'll move on how and what that means to you. So let's talk in terms of energy storage basics. Again, conventional storage, it's generation. Those electrons are stored in a traditional type of battery. Lithium ion is a type of battery you'll hear a lot in the market today, and that's stored for future consumption. The example that we're talking about today, specifically for you owners and operators in the cold storage space, is thermal energy storage. And this is storage in the form of cold. So the generation is pumped into the refrigeration. The refrigeration systems are run in order to store the form of cold. So we're basically storing that refrigeration capacity for use at later times. So TES, our thermal energy storage, again, stores that refrigeration output. and gives operators a more bargaining power with utilities. We'll talk in a little bit more detail of what that means. But bottom line is, if you are now empowered and you can have the ability to determine when and how you want to run your refrigeration and are no longer bound by the terms of I've got to run constantly to maintain a stable temperature for my customers, you now have the capacity to run on your own terms, store that energy, let the energy storage augment that cooling during long periods of time, and it can make a profound impact on your energy charges and costs. So this slide, we've provided several examples of thermal storage that has been around for many years. Traditionally, it's in the form of some type of ice storage or manufacturing or use of glycol and big tanks of storage where that ice or that is manufactured at nighttime when ambient temperatures are lower and peak pricing is typically not as high. And then during the day, those pieces of equipment are idled, the refrigeration or HVAC equipment is idled, and these pieces of equipment cycle through this glycol or ice formulations to augment the cooling. Typically, these technologies have been in the residential and commercial under the HVAC space. We've got other technologies such as Axiom Exergy, which specializes in what we refer to as medium temperature for grocery stores, where they have a broad impact over the whole grocery store footprint. But what we'll concentrate on today is, for those of you in the industrial cold storage spaces, is now there's a technology available specific for low temperature. Those are primarily targeted around frozen food temperatures. So thermal energy storage is permanent in its safe thermal mass. So why is that positioned that way? Well, as an operator, you have a certain amount of thermal mass in a freezer. You've got energy that's stored in the slab, in the racking, in the food in the facility, but it's got very minimal thermal capacity. Thermal energy storage in the system we'll talk about a little bit more today that's offered by Viking Cold Solutions uses a different type of thermal mass. It uses what's called phase change material. These phase change material, or these PCMs, store and release energy as they transition between solid and liquid states. These systems use natural convection to absorb the heat as it rises once it infiltrates the facility. And as those cells absorb the heat, they also continuously rain down cold air and bathe the food, maintaining a much more stable temperature for the food product during long periods of idle refrigeration. What I had mentioned a little bit earlier is about the latent or the heat values or the thermal capacity. One of the key pieces of information here is what differentiates this substantially from the food is that when these cells go through a natural transition of moving from a frozen to a liquid state, you now have the benefit of latent heat versus sensible heat. So as an example of that, frozen food is worth about, in terms of BTUs, so international audience, bear with me, but in forms of BTUs, it's got the capacity of about a half of a BTU per pound of mass, the ability to absorb heat. Comparatively, thermal energy storage using PCM has about 130 BTUs of energy per pound of mass. So it's an exponential increase in the ability to absorb heat. It's a 300 times increase in the ability. So now you've got this intelligent heat sink that's sitting in the top of your room using the laws of natural convection to not only effectively absorb heat, but actually rain down cold air and protect the food during those periods of idled refrigeration. Now, none of this makes sense unless you have some degree of intelligence behind this system to make it function properly. So you've got to have the intelligence to take advantage of the flexibility of managing the demand, of managing time of use, of managing your refrigeration, and most importantly, maintaining stable food temperatures when you're using this technology to help from a monetization strategy. Examples of that is targeting the peak demand period, reducing consumption, as I'd mentioned earlier, through high time of use periods, and then maximizing the refrigeration efficiencies. Thermal mass in the room, even if it's a phase change material, makes no difference whatsoever unless intelligence behind the system is allowed to help that existing refrigeration system know when to run. So whether it's a cycling of a fan, whether it's running active refrigeration, or whether it's idling for long periods of time, that refrigeration system can run much more effectively when ambient temperature is lower in cooler periods of the day, which are typically the nighttime and early morning hours. Now back to the cells, if you've got the intelligence looking at the room and constantly focusing on 3 different temperature measures, which is the air temperature, a product simulated temperature, and the temperature of the cells as they're going through the transition. Up to 85% of all heat infiltration is now captured in these thermal cells. The intelligence behind the scene is recognizing where those cells are in their transition journey, what we're solving for with a particular market given demand charges or time of use, or just running for greater efficiency and reducing overall kilowatt hour usage. Therefore, there are no mechanical components in the system at all. It relies entirely on the existing refrigeration facility in the system and using airflow from that refrigeration system for the heat transfer. Always a prioritization on the temperature requirements. You've got 38 to 50% more stable temperatures during these long periods of ride time. And you've also got 3 times longer temperature resiliency if you have an unforeseen event such as a power failure or a mechanical failure. So even though facilities have relied on the food in the past to either address emergencies or critical situations or try minimal amounts of time to ride on the thermal mass of the food, you no longer have to take those risks on as an operator and use your customer's food as a battery. So let's give you an idea of what some installations look like. As far as size and scale, the technology works in very small size. In this instance, we're talking about larger commercial applications, but so anywhere from 1,000 square feet or 100 square meters all the way up to 200,000 square feet, or a little close to 19,000 square meters are illustrative in some of these pictures that we're showing here today. The temperature range, primarily in the frozen food range. The phase change materials are specific to the given application, so there's a different formula in each cell. It's a combination of different types of salts and water. All the formulas and the phase change materials are water-based. All the salts are ingredients that are commonly found in food and very food-friendly. So there's no risk to the food with regards to the formulas. So in some of these pictures, you can see we've got mounting all the way at the top of the racking if there's a crossbar available. This example at the top of the page is an example of one of the sites in the Boston area where we've got just below that very top rack. We've got some other examples here in the middle on the bottom. You can see on the top of the ceiling, this is actually a Nestle facility in Northern California where you have the cells that are mounted to the ceiling based on the different racking configurations that were at that site. And here's another one on the bottom right hand where you've got another application where it's on that top rack, still allowing that top section usable for customer loading. The temperature range, again, is commonly the frozen food, ranging all the way from high fat content ice cream at minus 20 degrees Fahrenheit, all the way up to areas that for ice manufacturing into the plus 20 range for those applications. So as we're moving through, we're going to give you an example of an existing customer warehouse that's operating today in California. This is a 93,000 square foot warehouse, the period of time that the customer is flywheeling or using the thermal energy storage to float is about a 13-hour period. This is an extreme amount of time to have a facility idle the refrigeration, but it illustrates the power of the thermal energy storage versus an operator attempting to flywheel or float on the customer's food. We operate this facility during that extended shed 6 days a week. On Sundays, we have a steady charge or a refreeze period for the cells to put them in a fully charged state in preparation for the following business day on Monday. But the results at this customer location are phenomenal. We've been able to maintain the customer temperatures at the target operating range, and this facility has resulted in a 43% lower net energy consumption, 29% peak demand reduction, and 50% more stable temperatures. So it's somewhat counterintuitive to think that you can go for long periods of time with idled refrigeration without a temperature rise in the food itself. But again, as you can see in this picture, these cells in this application are mounted at the top of the room, very convenient to absorb the rising air, but also continually rain down heavier cold air, bathing that food in those cold temperatures throughout the ride time. Now we'll move on to beyond just a single application, but this is an example bringing back to the discussion of what's happening with utilities, the changing environment with regards to the grid itself, and what that means to customers and consumers like you. This is a utility-funded project that the Viking Cold team just completed. It was in the Massachusetts area under the Eversource utility program. This program funded 8 installations, including the largest third-party cold storage operator, the largest food service distributor, and multiple food processors in the area, including a nonprofit food bank, Greater Boston Food Bank. The average facility is roughly about 50,000 square feet, and the largest is close to 160,000 square feet. Some of these pictures to the right illustrate those applications and the installations. We've had a great degree of success. We've got the total of these facilities are allowing us to achieve our targeted demand reduction for the utility program, and also bring incremental value either through avoided costs for the customer or through additional revenue generation capabilities for the customer based on their ability to manage their power a little bit differently, target usage during the times that make the most sense from an economic standpoint, and reduce refrigeration runtime during the most expensive and high-risk times of the day for the utility. All of these equate to a good recipe for utility programs to help incentivize customers to participate with the implementation of new technologies, help ease grid constraints, promote the use and installation of green, renewable, and environmentally friendly technologies. And this is only one of many programs available across the country in the U.S. There are similar programs available in different countries, although I won't speak in any great detail today, but if there are questions that you've got or would like help, we'll work with the GCCA team to get you the information you would like to know based on programs that may be available to you in your own country. And again, group, I'd like to encourage you to please pose any questions that you have. I'd like this to be as iterative as possible and educational as possible. So as we...
Hey, Colin, we do have one question.
Right.
The question is the freezer in California full when you flywheel for 13 hours? And if not, at what percentage full are the racks? That's
a good question. These large industrial facilities constantly bring food in and out. So this particular facility runs anywhere from 85 to 95% capacity. So at any given time, and depending on seasonality, that capacity of the facility will vary. constant turnover of food that come in and food that is taken out. So I don't know that one facility, whether it's full during any given time, that would be detrimental or not to the technology. We've got customers that have capacity that are 50% capacity full, and we found that the installation of the technology in those applications actually help reduce the cycle time of the compressors. Typically, if you don't have a lot of thermal mass in the room, compressors and systems run and cycle much more often to try to maintain a steady temperature. So the thermal mass has a benefit in shallow rooms as well as full capacity rooms. This one in particular ranges from 85 to 95% capacity. Okay. And I can tell you, as I'm thinking through the question, this customer, and we've got data that we'd be happy to share based on customer approval, but this customer had attempted to flywheel or float on his facility prior to the Viking Cold installation. He had a minimal amount of time that he had, just a few hours at maximum, that he could basically shut down before his temperature range started to go out of compliance. The air temperature went out of compliance immediately. The food temperature follows air, obviously, but when we started to measure all aspects of the room, not just the bottom of the room that tends to stay much more stable because that's where most of the thermal mass in the cold air resides, but when you started to look at the top of the room. So when we started to install this facility, we installed controls and sensors throughout. We discovered that the variation and stratification of temperatures could be as much as 10 degrees difference, depending on the time of day, what their operations were like in a given day, and how the refrigeration systems were running. So that is one aspect that we have found to be somewhat challenging as the Viking Cold team looks at different facilities. Is where the temperatures are taken in the facility and the lack of information that's available for customers based on the food storage at the top of the facilities where the warm air typically resides. So hopefully that answered the question. So going back to the slide that's on the screen now, the expansion of load management programs. So we're trying to get a little bit more into the meat of what may be available to you based on our own experience. And you may have consultants, energy professionals from the retail providers. You may also have brokers that help you with procuring energy or price discovery. But the utilities, the retail providers, the grid operators, and the overall electricity landscape is changing so fast right now based on all the variables we discussed earlier, is that your knowledge of a program today that exists or a tariff that you may be charged today could very easily change within the next 6 months. Utility programs typically run from like a June start time frame through May 31st or sometime either before or after a summer period. So just be aware that a lot of the programs and a lot of the tariffs don't necessarily run on calendars. They run from seasonality, season to season, based on peak periods. And based on these changes in the grids, these tariffs have changed. We've seen in some cases where a utility will change its tariffs, if not yearly, multiple times a year, based on either demand or time of use charges, or changing on the windows of time. In California in particular, we went into some detail on the California duck curve where there's so much solar implementation. Well, the peak has now moved from 4 o'clock in the afternoon to a period between 5 and 9. So that seems really late in the day for most of us. But when that solar goes away and you've got all that grid that comes back on, and you've got California, and especially in Southern California, we've got a lot of heat, and consumers go home and turn on that AC, that really creates a big spike. So anyway, back to the strategies here. The monetization strategies is both from cost avoidance and revenue generation. So that's an important aspect. It's not just signing up for a rebate program and getting a small rebate back for for being a good steward and implementing some technology or a cost saving measure. But if you have flexibility and you can actually manage your load, the overall requirements of the grid in response to what utility needs are, it could be very, very lucrative. In many cases, the utility has even paid upwards of 100% of installations of these type of technologies over and over again. So programs are out there. One of our if there's nothing else that we make a point on today, it's that take the time to look at what's available to you and take advantage of those opportunities. So monetizing strategies are across multiple examples we provided here. It could be permanently load shedding over a period of time. That means we set a target period, and we let that system, that automated system and intelligence behind that system, shut down and ride for long periods of time on a specific set time every day. And in some markets, there are higher values that pay for that type of approach. There's targeted load shedding. Again, could be targeted towards reducing the periods of time where time of use charges are the highest, or trying to minimize or delete or take away an entire demand peak. Energy efficiency and demand response, two of the biggest and most important pieces to demand that are somewhat traditional. People are familiar with the term energy efficiency. It's the reduction of energy or kilowatt hours. Demand response is reducing that energy at that given period of time. Demand response is based on a market signal that is given from the utilities to reduce or curtail your load during certain periods of time. The notification can be anywhere from a day ahead to just several minutes. And in some cases, some of the utilities control commercial load and pay handsomely to have the control over that load. Our industry is a little bit different in cold storage, but demand response and energy efficiency, as we have traditionally known it, are also dramatically changing with regards to broader demand management programs, daily dispatch demand response type of programs, which reward you instead of 4 or 5 times a year of shedding your load based on market incidents, doing it more on a regular basis, maybe not quite a permanent load shed, but more often. So where you may see how in the world could I respond 30 different times during a summer period? That would be tremendously disruptive to my business. But if you have an enabling technology that allows you to store energy, maintain your food temperatures, and take advantage in an automated fashion of being able to shed that load and not even think about it when it's happening, you are empowered to change the whole scope of how you look at your energy procurement and how you manage your energy with regards to running your business. Solar plus storage. So we've talked a little bit about solar. We've talked about how solar has changed the variability of the grid. If the sun doesn't shine, all that commercial load comes back on the grid. So there are risks with solar. And so solar plus storage is an important play where you have, traditionally it's been solar plus batteries. In the world of cold storage, there is no more efficient and effective form of energy storage than thermal battery storage. So not a traditional lithium ion. What we're talking about here, we'll talk a little bit more detail about it and the benefits of thermal storage. But if any listeners today have entertained solar in the past or would like to entertain solar, pairing solar with a thermal storage scenario will not only help the economics of the solar investment, but also exponentially provide greater value than a traditional battery storage. Capacity programs are another one. So capacity, again, it's the responsibility of the generators to make sure and meet the absolute peak. So having that additional capacity on standby to address any unforeseen issues, a tripped power plant, having that additional capacity is all. So there's a charge on the bill, and there are programs available to eliminate that capacity charge as well by being able to manage those things. So again, cost avoidance and revenue generation, two distinct areas that you can actually monetize participating in some of these programs. So All of this is leading up to what does this mean to you, and how does this change the way you should think about how you purchase power? So think broadly, not just your own facility, or if you have a single facility, but if you have multiple sites. Do you have multiple facilities in a given region? Do you have the ability to aggregate some of that load to and perhaps give you more flexibility from standpoint of participation? Most providers that we have come across or talked to tend to sign, even for example, if they're in a retail market where they have choice to choose different power providers. They typically sign a fixed price contract. Fixed price contract means the utility is going to guarantee you that you pay a fixed price for energy during the period of that term. And the energy provider takes on the risks of the market variabilities. Well, now you've got to think about this in a different way. If you now have the capacity to shut your freezer down and idle those periods of time where it's the highest risk, you could now look at basically almost eliminating your risk completely and going to an index or a market settlement type of index price product that allows you to capture that, reduce the risk premium that you're paying to the power provider, take more of the risk, but now it's a managed risk. Now you have a technology that's available to manage that risk and take advantage of that lower power pricing. It can be very meaningful. It could be, you could reduce your energy, just your contract amount, at upwards of 25% or more by looking at an index versus a fixed price, depending on market conditions. Block an index. If you've got a large load, let's say if you're a megawatt or more at a facility level, block and index may be something that's good. A block is just simply, think of it as about a block of power that kind of handles the base load of steady power throughout the day, and then the index is just simply peppered on top of that to meet the peaks of the facility. And of course, this technology we're talking about takes those peaks away during the most critical times and high-risk times. Capacity and transmission pass-through. So there are multiple parts of your bill. There's energy, there's transmission and distribution, there are capacity charges. So if pass-through simply means that risk is being passed through to the customer, or an index type of products are synonymous with the pass-through. But if you have a technology in your facility that allows you to manage that risk of having those risks passed through to you, you no longer have to pay that premium. In markets like Ontario, Canada, very challenging market with regards to demand charges. So very interesting market on how it's structured with customers that use more or less than 500 kW of energy, and this global adjustment charge that's happened. Well, bottom line is the large users, if they're able to predict the 5 times of year at which those highest peak periods may occur, they may be able to eliminate their demand charges altogether. Being able to control that window of time during forecasted high use periods and deepen and lengthen that period of time minimizes that risk in those markets. So this technology is an extremely good fit for food producers, distributors, 3PLs in the Canada, Ontario market as an example. Retail supply energy exchanges. This is more so on how you actually go about purchasing your power. So if you have traditionally worked with the utility representative, or if you're in a deregulated market where you may have a representative from, let's say a Constellation or a Suez or a Jexa Energy, they all have a unique offering that they may sell you to do business with them directly. There are also exchanges now. There are electronic exchange platforms where you can actually put your load profile onto this electronic platform and have energy companies, 20, 30 companies bidding on your energy, where you have highly visible price discovery and have the ability to transact or at least get an idea of how things are shaping up in the market. So again, another tool which helps you access that technology available in the market. Aggregation programs, simply there are programs that aggregate different types of loads. There are school aggregation loads. I can see this easily happening in the cold storage area as well, as aggregation programs develop not only in regions but nationally as well. And then most importantly, there's a value stack here. What I mean by that is that depending on the region and the utility and your load, you may be able to participate in multiple programs. And we call that value stacking, where you're getting some demand management monies. You may be getting some incentive monies to participate in a program on top of that. And then for actually shaping your load to accommodate, you're stacking multiple programs together. And that could, again, come from cost avoidance from use and reducing your actual charges, or generating new revenue based on how you've been able to shape your load. This is a real world example. This is a customer in the New England area that had about 290 kW of curtailment. Each year, 19, 20, and so forth, these are a forward-looking year on how these different aspects of the bill have basically provided either revenue-generating opportunities or avoided costs. So ICAP is a specific period of day where transmission constraints and high peak usage tends to happen. That is a charge that is usually passed on and factored into the retail bill in the Massachusetts area. So with 290 as an example, in the years 2020 through 2021, there's $16,000 plus that we'll be able to reduce for this customer through that ICAP period that they would have otherwise paid in charges. The thermal energy storage value created just from reduction of energy is worth close to $19,000. The utility incentives and transmission and distribution charges that are abated during that period of time of load shed are a majority, which is a $72,500 amount. Peak period savings, $4,500, and energy efficiency credits that are given are another $15,000. So this is an astounding example of how this customer is increasing its ability to put close to $130,000 a year to the bottom line based on the use of thermal energy storage, its knowledge of the market, and leveraging the expertise necessary to take advantage of multiple programs. Very good example. Oops. Sorry for the sensitivity, team, on the computer. So energy storage and efficiency both. So kind of bringing it and crystallizing this down into the values of thermal energy storage in comparison into traditional batteries. In this example, the thermal energy storage system has a 20-year life, no maintenance required. Compared to batteries, there's absolutely no round-trip losses of having to charge and discharge through a traditional battery. It's an easy retrofit installation. It makes the most sense on new construction. There's no additional real estate required to house the cells. These cells are mounted into unused space in the racking systems, so you don't have to find another 1,000 to 2,000 square feet to store batteries. The LCOE is an industry term that has been created to standardize the measure of value on energy storage. It stands for levelized cost of energy. So if you compare solar, traditional lithium-ion battery storage, thermal energy battery storage, all of which have a levelized cost of energy over the life, which takes into account the initial purchase, the maintenance required, remediation of, let's say, a battery goes bad, what do you do with the old batteries? This technology we're talking about today, the Viking cold storage, thermal energy storage system, has a levelized cost of energy of less than 2 cents per kilowatt hour. How does that compare to a traditional lithium-ion battery? It's over 25 cents per kilowatt hour with a traditional lithium-ion battery. No additional energy required. So this technology is not parasitic. It doesn't use more energy during the off-peak in order to ride the long periods of time during the on-peak. It's actually got a dual benefit of not only being able to shed load during target periods, but there is less overall energy used. And that efficiency piece comes from running more refrigeration during optimal times of the day. during off-peak periods, nighttime, and gaining that lower ambient temperature, condensing temperatures. So manage your risk with the physical aspect. I'm going to try to hurry through these last slides to make sure and give time for Q&A. But this is a physical asset behind the meter in your facility. It provides you the ability to reduce your risk and quit paying risk premiums on fixed price power. It's a calculated risk now to lower your overall pricing. It allows you to leverage this physical asset behind the meter. Don't use your customer's food as a battery. This enables you to separate yourself from the market, use an intelligent system in a safe thermal mass, and not risk your customer's food in riding on that food in that thermal mass. You can purchase energy at a lower cost overall, and you could capture the available utility funding. This is the point I made a little bit earlier. If there's one message, take advantage of that funding that's available to you and improve all aspects of your facility. So I've got roughly a little bit less than 10 minutes for Q&A available. So Kenna, maybe you could help with prompting a few questions, but hopefully this has resonated with most of the listeners today. Once again, we thank you for being on board, and we are available to address any questions that you have.
Sure. To get started, there's two follow-up questions on the original question that you answered a few minutes ago about the freezer in California. The first one was, did they try flywheeling prior to adding the TES solution? And then also, what type of door system did they have?
Yeah, so that particular facility had two different rooms. One of the rooms had less heat infiltration. One had a lot of heat infiltration. They didn't even have a cool dock. So they had fast freezer doors, the fast doors that moved while they moved food in and out, but they had a lot of ambient temperature infiltration in the freezer. And I think I tried to answer the question a little bit earlier as far as how full it was, as far as the percentage of capacity. And then what was the other portion of the question?
The type of door system that they had.
Okay, yeah, it was quick doors. And then, yes, I gave an example where the customer prior to our installation had tried the year before to do flywheeling. And right away, within the first couple of hours of the flywheels, he would bust air temperatures, and the food temperature would move up accordingly as well. So he had very minimal time, and he put the food at risk. So we were able to minimize not only the heat infiltration in that particular application, but also provide that temperature stability to ride for that extreme long period of time.
Perfect. The next question is, how much weight does the TES add to each racking bay?
So on a vertical bay, there are two different cell modules, and that adds a total of about 100 pounds, a little bit less than 100 pounds per vertical. We only install them on the very top pallet position, so we don't install in every position, so that in that entire bay, it only adds about 100, a little bit less than 100 pounds.
Great. Can you tell a little bit more about the warranty of the solution?
Sure. There are two components, the intelligence, the electronics. The warranty, we expect the life of the system to last the life of the freezer, 20 years plus. We warranty the cells for 10 years, and we warranty the electronics for 1 year. There is no maintenance required in the system throughout the life. The cells do not have any problem with getting moisture or frost buildup. We design the systems to be up high in the racking systems where they're away from most of the door or infiltration areas. So hopefully that answers that question and provide a little bit more insight.
Have you ever had challenges or problems with them tipping over?
No, there's several different installation types. Some of the pictures you had seen earlier in the program where we just laid the cells down on top of the racking. If they use that top pallet position, we use a wire deck method where the cells sit neatly behind the crossbar. Actually, this picture we have up right now is a really good example. So that top pallet position is available for loading on the top. The middle pallet position, if a pallet gets too high, normally it's blocked by the crossbar, but if there's something that may be sticking out of the top of the pallet or a broken pallet, those cells actually are on a wire that swing out of the way. So they move on that wire deck. So we've gone through many iterations to make sure that we've got a very usable and, let me say this, forklift driver friendly application.
The next question is based on that picture, so kind of building on that. Is there additional protection needed from getting hit by the product?
No, similar as I've mentioned is the pallet position in the middle, right above the heads of the gentlemen standing there. If that pallet is too high, even if it's high enough to hit the crossbar at the top, if it hits the cells swing out of the way. We have yet to have a damaged cell from a forklift from any of the wire deck modules. And we've got some operations that have been in place for over 7 years. Our installations are across the U.S., majority of which are in California, the Northeast, New England, Mexico. We recently installed the first system in Sydney, Australia. We're very prevalent in the broader Caribbean. We've got close to a dozen facilities installed in Puerto Rico.
And the last question we see here, Colin, is can these be purchased? Can the systems be purchased, or are they only available as a lease?
We prefer and work with customers to sell the systems as a service. So if there's a capital expense concern, we're able to provide the investment of the system, the installation of the system, guarantee a positive cash flow scenario, and the customer basically has all the benefits of the backup resiliency, the temperature stability, the ability to abate more of their energy charges and costs, add generating revenue opportunities, and not have to come out of pocket with any capital. So that's our preferred method of approach. It seems to be working very well with our customers.
To build off that lease or that service model, can you explain a bit more about the pricing and logistics of the monthly monitoring?
Absolutely. So the monitoring is a very important piece. Is that we've got visibility for 24/7 on the facility. We measure not only performance against an agreed upon baseline with the customer. So we give them a daily report that they see every day on how we're performing, how we're managing 3 different measures of temperatures: the air temperature, a product simulated temperature, and the cell temperature. We're able to show how we've managed their kilowatt hour usage and how we've managed the demand during the period of day. Any tariff changes or rate changes or structures that have been implemented that we need to adjust, we simply provide an update via web-based software application, very simple. But the monitoring is one of the most important pieces of and value propositions of the system. It gives great traceability back up to whatever reporting or technology they may have in place with regards to temperature requirements.
Great. Colin, that's all the questions we have here right now. Is there anything else you want to add before we log off today?
Well, we'd like to thank our GCCA partners and the WFLO for sponsoring these educational series. Hopefully we've been able to provide a worthwhile education, and we appreciate your time. Thanks again for everyone online who has participated in the webinar. And please reach out to us. VikingCold.com is our website. My name is Colin Coker. I'm happy to assist in any way I can with any additional questions you have post-webinar. Thanks again, Kenna.
Great. Thanks, Colin, and thank everyone for logging in. We'll send a follow-up tomorrow, like I said, with a survey and then a recording of the webinar. So you're welcome to refer back to that or share it with your team as much as you'd like. Feel free to reach out to Viking Cold Solutions or GCCA headquarters, and we can either answer your questions or connect you with the right person. Again, thanks so much, and we will talk to you all soon.
Great. Thank you, Kenna. Bye-bye.